Good evening, good afternoon, good morning, and welcome to the Marintec Innovation webinar series. I'm Michael Duck, a Director of Marintec China and Executive Vice President Asia at Informa Markets based in Hong Kong. I'm very pleased to have been involved with this exhibition held biennially in Shanghai since 1994. This webinar today is Chapter 3 of the first Marintec Innovation webinar series that will hopefully give you insight into some of the key technology initiatives in the maritime world today and for the future. Today's audience happily numbers almost 750, and I can see from the list it includes many key maritime people and organizations and associations from all around the world. The title of today's webinar is The Fourth Industrial Revolution at Sea, Advanced Digital Systems. To give this paper, it gives me very great pleasure to welcome today Dr. Martin Stopford, an old friend of Marintec China, and as I'm sure you will agree with me, is the foremost economist and thinker in the maritime world today. His books and academic papers have been used by the maritime industry for decades now. He is also non-executive president of Clarkson Research Services. Dr. Martin is joined by three eminent panelists from the maritime technology world, and I welcome them joining us here today. From the UK, Mr. Ronald Spithout, President, Inmarsat Maritime. He is responsible for Inmarsat's maritime business and its global commercial strategy and execution in merchant marine, offshore energy, fishing, passengers and leisure markets. In his previous roles, he was also President of Enterprise Business for Inmarsat. From Oslo, we have Mr. Christian Muller, Senior Vice President and Chief Technology Officer, Kongsberg Digital. In this role, he plays a central part in the development of the company's existing products and also new ventures. Mr. Muller previously worked in research for Microsoft HQ, and he holds a PhD in 3D technology from MIT and Cambridge. And lastly, from China, from Beijing, Mr. Li Yangqing, Chairman of ISO TC8 and Secretary General, China Association of the National Shipbuilding Industry. Mr. Li has long represented China to take the post in the Technical Committee on Ships and Marine Technology at the Organization of International Standardization. And as chairman, he led the team to make pioneering achievements in stipulating the rules of the international shipbuilding and ocean industries, and was awarded the Lawrence Archer Leadership Award by ISO, who was the first Chinese chairman winning the honor. The format of this webinar today will be Dr. Martin's introduction of a keynote presentation, and this will take about 20 minutes. Then we will have 20 minutes of questions and statements, interaction from the panelists. After that, in the final 20 minutes, we will take questions from the audience. And if you have questions, please submit them to the Q&A box at the bottom of your screen. I'm sure you will enjoy the presentations all today. And please do enter your questions in the Q&A box. Dr. Stopford, over to you.
Michael, thank you so much for that kind introduction. And it's such a pleasure to be joined by this panel, which is just perfect for the subject, I think. The topic, as Michael told us, is advanced digital systems. And of course, it's easy to talk about the digital revolution in shipping, but talking's one thing. Actually believing that it's going to happen is another. If there's one thing I've learned in business, you may make predictions for the future, but believing them is another matter. And so my aim in this brief introduction is to try to convince you that the digital revolution is something that is going to happen in shipping for very good reasons. And that's exactly what I want to talk about this evening. So what I'm going to do is now share my slides with you and talk over a short slide presentation that I have, that I prepared. So here we go. So now you should be seeing my slides and the opening slide with the title. Just a moment. Excuse me, sorry, always the question which button you press, which I guess is very relevant to the topic we have to this evening. Advanced digital systems, I'm going to talk about what they do, how they work, their crucial role in shipping strategy for global cargo transport and emissions, and of course the regulators, and hopefully we'll prepare the ground a little bit for the expert panel who bring much more technical knowledge than I have. And I'll do this in three parts. First, I'll talk about the three maritime digital networks, which we have been using for quite a long time, in fact. This is the fourth one we're looking at. I'll talk about using digital networks to revolutionize ship performance. It's something, I mean, I was in shipbuilding for 10 years, and the ships we build today are not so different from the ones we were building when I was in shipbuilding in the 80s. I think that if you come back in 30 years' time, you'll find a very big difference. And all of this is going to be possible because ships are no longer standalone entities. They're actually businesses which can communicate very well by a rapidly growing satellite communication network. I'll say a few, I've got one or two of Inmarsat's slides, which I'll link into the end, hopefully to prepare for Mr. Spitu's comments. So that's basically my agenda. And the first topic is the three digital networks. And basically, what we're talking about is how we're going to add a fourth network to the three that we have worked with for a remarkably long time, actually. 150 years. The first digital network that the shipping industry worked with was the cable network. The first ship owners, a very big ship, laid the first cable across the Atlantic, the Great Eastern, in 1862, it was, I think. And from that point, you could send telegraphs. It was a massively productive business for the shipping industry because you could fix a ship in Calcutta with a cargo in another part of India. And the only way you could do that was by sending cables between London and the 2 points where the cargo and the ship were. Brokers worked very hard on that. In 1874, Clarksons actually spent more money on telegrams than they did on wages, if you can believe that. And so the cable network today is much bigger, much more complex, 20 trillion. It's now fiber optic network globally, 125 billion messages a day, with email and lots of other traffic going along it. So that's the first network, the subsea cable network, which is sort of the backbone. And then complementing that for ships is the satellite network. It started with radio communications in I think the early 20th century. Inmarsat was set up by the United Nations in 1979, though it's now a private business, and the satellite network has grown steadily and very substantially over this period. And so I'm going to talk a little bit about their plan, Inmarsat's plans for developing the satellite network going forward, which is one of the most important issues in this whole process. And then thirdly, in the 1960s, computers arrived, and the computers were able to plug into, this is a CDC 6600. It was the first supercomputer. It had a clock speed of 10 megahertz and 980K of memory, if you can believe it. And it's linked into the cable network. And this was very fundamental for shipping, because the newly formed container business had could use electronic data interchange, EDI, to report container sales, transport sales, and ensure that the different parts of the global container network had up-to-date information about the cargo manifests. So that was a very big step forward. But then the big thing on the computers was that the integrated circuit boards got smaller and cheaper. We've had mobiles, mobile computers, smartphones. Microcontrollers is the very big thing as far as what I'm talking about today. These are fully fledged computers. They have a processor, they have memory, they have input-output devices. And in fact, this particular one, it is actually more powerful than the CDC 6600 of 1966. The only difference is that the CDC 6600 costs $7 million. You can buy these for about $1 a piece, or perhaps a little bit more. This is a fancy one. If you put enough of these microchips into things, you get this long heralded phenomenon, the Internet of Things. You put a microchip in your coffee percolator and you send it a message when you're on your way home, and it will turn the percolator on. So that's jolly good. Of course, it's not clever enough to go and get the coffee out of the cupboard, but we're getting there. And the second strand with this, which started in the 80s and has continued since then, was the I-4 revolution in industry and land transport. And I think there's plenty of examples of how land transport has been truly revolutionized by the ability to manage large quantities of data through the cloud, and through messaging services, and through the ability to embed microprocessors into vans and motor cars and so forth, which really has transformed that business. And so what we're now looking at is applying this I-4 maritime technology to the maritime network. It's basically about using processors and sensors to generate information and communicate it in a way which improves the efficiency of the business. And basically, we've got a bunch of devices that you might put on a ship. Of course, the beginning is the advanced satellite services. And that's truly revolutionary, because you're coming to an era where you really can communicate in very effective terms with ships at sea, which for 5,000 years wasn't really the case. And so that the ability to bind ships into a company business operation linked by digital technology is a very big part of this. The cheap microprocessors allow you to do jobs. These have only come in the last 10 years. You couldn't have done it 10 years ago. You can embed them. It's not just sensors. You embed microprocessors and controllers in smart sensors, and you start to get the sensor not just to collect information, but to process it and to do things if you want to. And smart actuators, if you want to use a machine, you have to switch it on. Electronic switches can also be fitted with microcontrollers, which allow you to do all sorts of things with managing that machinery, collecting data from it, appraising that data, doing diagnostics, and managing the machinery in a much more effective way than you could do by hand. And then finally, artificial intelligence that just takes you a little bit further. The next step on this, we've got our devices and our software. We need actually to communicate between them. The other part of the I-4 and the Internet of Things is communication, and that's what advanced digital networks are about. The first thing you need to communicate between these devices is a network. The computers talk to each other by sending messages, Perhaps not messages as you're used to them, but they are messages. And to do that, you need unique identifiers. Every little chip on the system needs to be identifiable so that any other device receiving a message knows where it's come from. And if you're going to have all of this information going around a network, you need rules, you need protocols. And the more standard those protocols are for an industry like shipping, the better, because frankly, if you've got a fleet of 50 ships and you're trying to collect data from them and they're all sending information under different protocols, then that's very difficult. Smart apps, we're all very familiar with smart apps on iPhones, and these can work just as well on ships for doing lots of specialist jobs. And voice and touch interfaces, once you start looking at this, it's amazing what you can do with these things just to make difficult, boring, not very accurate jobs much, much better. And so that, if you put all of these together, we have the Internet of things on ships, or the I4 digital revolution. Well, using networks to revolutionize ship performance, that's my next step. And I just want to spend a moment talking about how computers work, because I think one of the key things about this revolution is it will only happen if everybody understands how the technology works. If it's all left to the people in the computer department, I think, you know, long and bitter experience proves it doesn't always work as well as is hoped. So that I think the getting in touch with the basics is very important. And in fact, computers communicate with digital data, binary strings. That's the only way they, or basically the way they communicate. And smart ships will have many computer devices sending messages to each other, you know, tens of thousands. I mean, I don't know how, I think 3,000 or 4,000 devices on a container ship, 30,000 devices on a big offshore rig. This is a lot of devices. And any device receiving a message needs to know how it is encoded. In other words, the computers deal in digital strings, but the digital strings, like any language, have to be interpreted. Let me give you an example. This is a modern valve, a digital valve. It's got an electronic controller and a motor which will open and close the valve. And it's also got a manual one. Just to illustrate the point, suppose that the degree to which the valve is open is measured by a digit 1 to 5. So if the digit 5 tells you the valve is completely open, and you see that on this particular screen, it's showing that 5, which indicates the valve's open. What we want to do is to send a message to the guys in the control room, tell them that this particular valve is open. And so the way you do that, we're going to, just to illustrate it, we're going to send a message in ASCII text, which is a conventional text format based on digital code. And so the message we're going to send is 5, and this table here is an ASCII chart. It's one of the originals from 1970. And if we take a look at there, you see that there's the numbers here in this column, the letters are here, other units are here, and the number 5, to find out what the digital string for number 5 is, you look across here and you find the first 4 digits, 1010, you see there it is, 10, and then you go up and there's 110. You put those together and that is the digital string for 5. You need to know that it's ASCII, and without this table, the computer won't know what it means. So then you send the message and it's received, and it's then interpreted back into ASCII. And so the operator here reads the number 5 on the system. And so you can see that the process of sending messages, or messages have to be coded. And the big problem is that if everybody codes up the digital string separately, you get a very complicated situation. And this is the format of a typical message. It's a canvas message format. The data is in this, there's 64 bits for the data in the middle of here. That's all you can put in it. And this will be digital strings. And then here are the various fields which tell the computer what it's all about. It's the frame or the message starts here, it finishes here. This is where it's come from, where it's going to, and then various other bits of information. So the reason I've dwelt on that is just to really drive home the fact that the more we can standardize the coding up of these messages or frames that the computers send to each other, the easier it's going to be. And if you end up with 50 ships all sending each other messages in many different formats, it's a bit depressing, frankly. So let's assume that we're going to go ahead and do this. Then in future, the messages will, what will happen is that messages sent over a network will replace the wiring on the ship. And the reasons we'll do this is because it's cheaper. You get rid of a whole lot of wiring. The car industry found this, you know. And indeed, as you put more electrics on the car, you know, it was you just couldn't handle the amount of wiring because, you know, every switch had to be wired to the motor that it operated. And so you get wires all over the car. So it turned out to be much cheaper and it saved resources. Secondly, it's more efficient because you can add safety and control algorithms. You put little programs into the message can activate algorithms which do things like check that you haven't got a spike in voltage when you turn a motor on. And if it detects a spike in the voltage, it immediately turns the motor off. And if you didn't have that, you just an ordinary switch, it'd just blow the motor, you know. It's efficient, it makes QA work better because error diagnosis routines are built in. You don't have all these bits of paper from QA systems. It's robust from electrical disturbances because digital data really generally isn't so vulnerable to electrical interference, and it's flexible. It makes it easy to roll out upgrades. I mean, you've got to think about this. If you're going to put all this kit onto the ship, and these are the things that we're going to be digitalizing, you put all this onto the ship and you try rolling up upgrades every time you want to change something, put in a better system, and it's a nightmare. So hopefully I've made my point on that. Standardization would be wonderful. And how fortunate we are on the panel to have Mr. Lee, who is a chairman of one of the ISM committees, and the Maritime ISM committee. And let me finish off by talking about the key role of satellites, because I always think that the satellites are they're the spider in the middle of the web. We need the satellites to make shipping an integrated business. And basically, the key points here are that we're in a period of very high investment in new satellite capacity. I'll show you in a minute, but billions and billions of dollars are being spent on this. The new satellites each new satellite seems to get better. The previous ones had beamforming. They could focus the bandwidth in areas that were busy, but the new satellites actually have algorithms that automatically optimize the focusing of the beam. It also manages the backup so that you get fewer dropped lines and better continuity. I think everybody's very familiar with that. Hopefully you can all hear me and you haven't dropped my line. The last talk like this I gave, it turned out at the end that you couldn't hear me half the time, so I had to do it again afterwards. Version compatibility, it's all being done so that it's backward compatible, so you're not going to be left with obsolete equipment. And shorter lead times, you can put up a satellite in less than 2 years. And basically, these dotted lines surround the satellites that are up there and operational at the moment. There's 4 of them. And this is what's going to happen in the next 2 or 3 years. And not only is it many more satellites, including these, but it is also these satellites, some of these satellites are, I believe, 4 times more powerful than all 3 of the most recent ones put up to date. So the satellite capacity is expanding very, very rapidly. Inmarsat is putting their money where their mouth is. And I think it's up to the shipping industry to make sure that we make full good use of this and get real value added out of it. So in conclusion, advanced digital networks of microcontrollers will revolutionize ship operations. It's already happening, and I think Christian Mollers from Kongsberg, which are right in the heart of this, are going to tell us about that. Developing network protocols for big cargo ships would streamline fleet management and emissions reporting. The whole thing is easier to the extent that you standardize the protocols. Not easy to do, but if you can do it, for especially shipping, where you've got many ships in a fleet and ships move between fleets, I think this is really important. And it's going to be fun because we've got Silicon Valley meeting the world's oldest industry. Well, perhaps the world's 2nd oldest industry. So on that note, Mr. Chairman, could I pass the baton back to you, please? Thank you.
Thank you very much. Let me stop my video. Thank you very much, Martin. Fascinating presentation. I'm sure everybody thoroughly enjoyed that. We do have at the bottom of the screen the Q&A icon. Please do put your questions in there, and we will run through them and ask questions to the panel. So we can start now the first panel discussion with the panel guest speakers. And maybe we can start first with Ronald, followed by Christian, and then Mr. Lee. So the first question to Inmarsat, Mr. Ronald Spithoud. Dr. Stopford has just told us about the impressive satellite communication system that Inmarsat is building. What is your vision for how the industry can make the best use of this in the decades ahead? Ronald, you're on mute. We need to unmute your. Can you unmute it? Yep, that's okay.
Is this better?
All right. That's fine. No problem.
Okay.
Please go
All
ahead.
right. Well, first of all, thank you very much for having me here, Michael. And it's an honor to speak to so many of your participants over here. And the question is, well, you used the word decade, and actually it's much shorter than that. Martin already alluded to that. Nowadays, the lead times from design to deployment of satellites is much shorter than it was in the past. And if you now look at, we started in around 2015-16 with the deployment of the Global Express network with 4 satellites. And if you look at where we are now, between now and 2023, this constellation of networks will grow to 12 GX satellites. And indeed, every time we are launching a new satellite, it is more powerful than the whole network together at that moment. So currently we have 5, and we will expand this rapidly in the coming years with GX satellites and also L-band satellites. And by 2023, that will have been completed with polar coverage as well. And the reason why we do it in this way, which is completely different than any other satellite constellation operator, is that we are very much a maritime organization. Always, when we deploy a new constellation, our constellation's first goal is to make it global. Because for the maritime industry, there's nothing more important than a global coverage and a seamless takeover from one beam to another. So therefore, we start always with a global network on L-band and on the Ka band. While other network operators are always starting from a high density land-based customer base and then moving into the lower density markets like at sea. We do it the other way. We first go global and then we keep on adding satellites there where it is busy. And that gives us a benefit because we are moving from low density to high density. And that benefit, economical benefit, is our benefit, but also the customer's benefit. And because those satellites are more powerful every time we add them, you see that at sea, where currently an average vessel is using hundreds of gigabytes per month to transport all those data that Martin alluded at. Now, where can they get these benefits from? Basically, a vessel has multiple items to operate. It is a machine on itself. It is an office. It has an accommodation functionality. And of course, it is a traveling business unit. And each of them have different needs to fulfill. And because the capacity of the satellites are going up so rapidly, a lot of these operational needs, for instance, the office operations, ERP operations, crew welfare, video, voice, internet, that all is already standardized on shore. And because the satellite capacity is going up so rapidly, they are nowadays easy to deploy at sea. And therefore you see rapid deployment of ERP software. And just the standard things like we do now, Teams or Zoom or WebEx or whatever, you see now being deployed at sea because the capacity is there. Now, what we try to do, and we currently have deployed about 10,000 of these platforms, is to underlie the capacity with an agnostic platform for IoT and application hosting. And we noticed that one of the biggest issues of the shipping industry is to get meaningful data from and off the vessel. And for that, these platforms are now accommodating and enabling IoT in a very easy way. And that is the start of this whole fourth generation network evolution. Starting with cost savings, starting with efficiency, and then making use of the same IoT data to benchmark the vessels, and eventually change the way shipping industry is doing business. And we thought about 2 years ago, when we were looking at this, that the very first wave was always about cost saving and making sure that you were shaving off all the operational cost of a vessel where you could. But we see now that in this time of pandemic and this looting crisis that will stay with us for a long time, and having low energy costs for a while, that it changed in the way the shipping industry is focusing on how to use IoT. It is now much more important that you are matching demand and supply, that you are streamlining your supply chain and your port communication, than it is to only watch operational efficiency. That is only fueled by platforms that really can simplify the way you get your data on and off the vessel, because you have to react quickly, and that's what we see currently. Is that answering your question a little bit? It's a lot at the same time, I realize, but that's what is happening out there.
Thank you very much indeed. Does any of the other panelists want to comment on what Ronald had just said? Martin, maybe?
Well, I think it's what's quite very interesting from what Ronald's saying is that since we're talking about networks at the moment, most ships probably have run some sort of office network. I mean, for example, Ronald mentioned to the move towards using Microsoft Teams and things like that. And I perhaps not now, but I would be very interested to explore how closely offices on land and on ships, where you've got biggest ships, are able to work together, and how willing people are on the ships to work together in that way.
Yeah, Yeah, but for that, you have to innovate in two ways. So on one hand, you have IoT, right? An endless stream of all the sensory information that you mentioned, right? Bringing a platform, an agnostic platform to sea, so that that data can be taken off the vessel in a uniform way and can transform into meaningful information for the officers on shore. So that is one way. The other thing is using as much as possible standard applications. And this is where the big capacity comes into, right? Because if I look what is happening on a vessel, the vast majority is going into video and streaming and these kind of things, which is also important because it is Teams and Zoom on one end, and it is to accommodate welfare for the crew, which translates into safety again. So it is on one hand making the platform as agnostic as you can to have that meaningful data coming to the shore in a standard way. And on the other hand is providing as much as possible capacity to the vessel so that they can start to use standard software. I think these two things are the most important drivers for our activities today.
Thank you very much, Ronald. Second question then to Christian Muller, Kongsberg. Christian, we've heard from Ronald that satellite capacity for accessing the cloud from ships will grow rapidly. Kongsberg has recently produced a new product, Vessel Insight, for linking shipboard systems to the cloud. Could you explain what it is and what it will mean for ship owners?
Sure. Just first, can you hear me, Michael?
Very well, thank you.
Good. Yeah. So I thought I could start off maybe by touching on the points of Dr. Martin when it comes to sort of bits and bytes. I'm talking about automation systems, and if you look at that presentation, you can see, I mean, so he was presenting CAN bus, you still have analog buses on vessels. And as Kongsberg has been building automation systems, our latest generation automation system, which is called KCS, is much more of, I would say, a software platform than it is sort of wiring and bits and bytes. So even the automation systems are building more and more sort of abstraction layers from the devices, the embedded software, etc. But it's still an automation system. And so what we've tried to do with Vessel Insight is to try and look at that asset, the vessel, more on a macroscopic level. And it's been touched upon here also by Ronald. So the idea is, well, given the automation system contains a lot of what's going on the vessel, not everything. So you still have isolated systems like the bridge. You might have deck machinery, other sort of things which is not connected to the automation system. But I typically in my head group them in sort of 4 or 5 piles. If you had access to all of these, let's say mini ecosystems on a vessel, if you could somehow I'll use the same the word as Ronald, agnostic platform for connecting these together. That's what we're trying to do on the ship side, right? So make it easy for all these systems, in particular the automation system, to find a gateway eventually to the cloud. On the cloud side, then we're trying to organize that information in a standard way so that if you were a ship owner and let's say you had 20 vessels, those vessels would be mapped up and have the same data structure for all 20 vessels, which means if you had an application, that application would actually fit and work with all these 20 vessels. And if we can do that for a larger sort of fleet and fleets, obviously for those developing applications and value-added applications, they can access the same information model, effectively meaning, and this is maybe a bit technical, but what we're trying to do really is to create an API, right? So a software interface where every vessel underneath there looks the same. And so that is, I think, absolutely achievable. It will require that that the larger OEMs and vessel owners, certainly the larger vessel owners, work together, but I think that's absolutely doable. And a few more pieces to add to that. So once you have this in place, then obviously you can take these applications and also push them back onto the vessel. So like Ronald was saying, let's think about that as sort of a, I really don't like this word app store, but let's just use that because it probably makes sense to a lot of people, you know, some sort of onboard application repository where you can access applications online. And it can change the entire way you work, and you can start working much more in which the consumer side have been working for ages, where you can push updates and patches and security fixes and all of that. You can do a mass deployment. You can imagine if you developed an app, you can push a fix to 10,000 vessel with one click, right? Whereas today, that's just not doable. You typically will have to send something to the crew, and they'll have to find the PC where it is, and maybe they have to go through some security clearance, etc. And it's just much more laborious. Last thing I want to point out is, and I don't come from the maritime industry, so in my view, it's quite arcane, and I can see why it is like that. But also, one of the problems with a lot of these systems is they're fairly isolated, right? So the automation system is a fairly isolated system. You have energy management system, you have bridge, etc. And there's no easy way for these, let's call this groups of systems, to communicate amongst each other. So another thing you could achieve with this sort of, let's call it a platform or gateway, is you can also have communications among systems on board. Right? So you can imagine a piece of equipment somewhere on the vessel actually wanting to pull alarms off the automation system. That today isn't very easily done, but that's also what you could achieve. So I hope that made sense. And I hope it's some way to explain Vessel Insight. Usually what I say is that it's a data infrastructure to take data from the vessel to the cloud, and the other way around, but that's right now, I think, less important for a lot of ship owners, but it's really a data infrastructure.
Thank you, Christian. Anyone from the panel like to make a comments on what's just been said?
Well, yeah, well, the key, as Christian said, is agnosticity of the platform, right? Because right now, indeed, a lot of the bridge systems are not yet at par with what you've done in the machine room, but they need to come as well, because eventually, if you have that agnostic platform supporting the exchange of IoT information, it is not only that you can start working on your agility where it comes to the business, but also on safety. And I think eventually, and we are working very hard on that, eventually this all comes into the era of much more automated safety, where you know on shore much more what is happening and how you can interact with the vessel to make sure that it does what it needs to do. And that comes not only to vessel maneuvers, but also how's the crew on board. So it is that you have to combine not only the machine, but also the operations, the bridge operations, and the crew welfare. And all of that is actually IoT that has to run over an agnostic platform, so that you're not depending on one or of the other to make sense out of that data coming out of it. So for me, agnosticity is the biggest item that you can strive for when you're automating on a vessel.
Mr. Lee, I saw you had your hand up. Would you want to make a comment?
A very brief comment that Christian just said. He's not from the maritime industry. So I believe that most of the people working in the maritime circle, they are not so familiar with the new cutting edge technologies. So maybe it's a great challenge or some problems for the ship owners and all the traditional stakeholders in our maritime industry that to accept the new concept and risk applying a series of the technologies to change their business mode. So I get the information that from the practice in Norway, that the Yara, the very pioneer, the vessel, the autonomous container ships, that's the ship owner is from the logistic. I believed it's not the traditional ship owner. So this is a very, I believe, the typical case. They consider the supply chain's efficiency. They don't care about the very short range, the shipping, the line, the efficiency. So this some kind of new changes. I believe that we need to focus on this kind of problems. That's it. Thank you.
Thank you, Mr. Lee. Christian, wanted to say something now?
Yeah, no, I just wanted to sort of give him some air support on that statement, because that's sort of coming into this industry. That's sort of what I observe. If you take Yara Birkeland as an example, the electric autonomous vessel, Yara does not own any vessels, nor were they really intending on owning any vessels, but they wanted to get rid of all these trucks that they're driving from A to B, which is not a very far distance. And that business case really only made sense if it was autonomous. And so it started of a lot of this. And as you can see recently, we've had announcements now of new autonomous vessels that we're building. And certainly when you're building autonomous vessels, you need to think differently, even about down to the bits and bytes. Sure, you're going to have an automation system, and you're going to have a lot of the sort of conventional systems on the vessel, but you're operating it in a different mode. And you need to think differently about redundancy and safety, etc. So I think these autonomous vessels will, or sort of the move towards them will change. I mean, I can't predict the future, but I think it will maybe even go to the point where it's going to change how we build ships. But I don't know. But I can certainly see that that it's challenging a lot of the conventional ways in which at least Kongsberg has delivered its systems and equipment. So yeah, so that's that is very interesting. I wanted to make one more point, which was I also work quite a lot in the oil and gas space, and in my mind, from a technical point of view, oil and gas and shipping is sort of very similar, right? You have automation systems; they're just much larger, and you have much larger systems, but in many ways, it follows very much the same pattern. And although the business and the challenges and the competitor landscape is very different, so I'm not saying that it's going to play out the same, but I can still see that that the challenges that they need to fix with their heavy assets are also the same that I see in the maritime, and it has to do with that. Yeah, there is a lot of data there, and I think there is a lot of value in this data. And fine, one day, we can apply and drizzle it with a lot of machine learning and AI and all of that fancy stuff, which I really believe in, don't get me wrong. But we still need to sort of clean up and get the basics right. And that's going to require cooperation, and it's going to require also some sort of acceptance that needs to be done. And then these more visionary revolutions such as machine learning and AI, yeah, they will come, I'm sure, but I think it's right now there's still basics that have to be in place to get that to work on a large scale.
Thank you very much indeed. So on to the third question, the question to ISO, Mr. Lee Yanqing. Mr. Lee, we know that you are the convener of WG10 of ISO TC8 on smart shipping. What's the main topic in your working group and your opinion about standard development to this area?
Okay, thank you. Thank you for your invitation to join this very interesting panel. So I totally agree with the presentation that just made by Martin, that he has a new category for the network, for the phone network. I believe that it's iterated from one generation to another, and they are not substitutional relationship. They co-existing now in during this time. So, but for ISO TC8 Working Group 10, we focus on the smart shipping now. The program, the projects mostly comes from the network on board. We discuss about the topic on board network. For example, we have some registered projects on the onboard network, servo, and the functional requirements for ship-to-shore communication. And also we discuss about the protocols, IPv6 based network. So it's very scattered topic. Actually, we depend on more practice and more experts to join us. We never discuss about the communication, satellite communication, because we just expect more experts from EUMETSAT to come to join us to discuss about the network outside of the ship and the network on board So maybe in the future, we may need to talk about the encoding issues for the device and satellite network and the ship-to-shore communication network, and also the message, the format. But for the time being, we still need a lot of experts to join us. Actually, for my opinion, I believe that we also need to focus on the cyber security issues. We also have the working group 4 on the maritime security, but it's very sensitive. Now we have the one registered project on the safety, onboard safety assessment. There are so many software, so we just have want to have the standard to support the assessment for the safety issues on board. So it's very difficult, even though for the technical application side, there are so many experts, they have some applications, some cases to use the new technologies on board, but actually for the standardization, we still need a lot of time to wait the practice, because we need a lot of time to talk about that, to have the consensus. It's very difficult. That's it.
Thank you very much. Any of the panelists like to say anything about what Mr. Lee's just presented?
Yeah, I would like to, if I may. Or Martin first, maybe?
No, please.
Ronald, go ahead.
But I'm very encouraged by what Mr. Lee just said, because I think he is touching the most important topics in shipping currently. It is cybersecurity and safety and ship to shore. And I think underlying there, you have the big question about what to do with propulsion and fuel and emission. So how to make this all sustainable, because far before we are coming to autonomous vessel, we have to take decisions on what is happening to the vessels that are currently at sea and what is happening to the vessels that are currently coming from the yard. So I would be more than happy to send people to his committees where it comes to start discussing standardization of ship-to-shore communication, because if we are getting into this journey of greener shipping and where ports are demanding ships to be green, it all needs to be monitored and controlled, which has a big impact on how you communicate ship to shore. So definitely the right topics there, Mr. Lee.
Martin, you wanted to come in.
Oh, well, yes, again, like Ronald, it's great to have you on this panel, Mr. Lee, because you're the guy who's going to solve the problem for us, right? No, I'm just kidding. I've got 2 points. One is, I don't know, I understand the CIMAC have a working party which have been looking at the requirements for protocols, the priorities, not actually looking for at building a protocol system, but they've been looking at the basic requirements, and I gather they're going to publish something in the autumn about that, which I think would be quite relevant for the engine side and the propulsion side of the business. And the other thing is just an observation, going back to both your comments and Ronald's comments, that I mean, what really pushed the car industry down the standard network path in the 1980s was the requirement from the environmental lobby for the onboard diagnostics. They wanted accurate information about what was going on the ship. And eventually they came up with the OBD protocol, the onboard diagnostic protocol. But in order to make that work, they had to then do the CANBUS protocol for the cars. And I think that this question of the diagnostics on the ship is a really interesting, I think Ronald's touched on it, and I think, and you sort of touched on it, and so did Christian, but it would be such a good thing to, if we wanted to give the industry a better reputation, and with the cargo owners, it would be fantastic if you could get something critical like that, you know?
All right. Mr. Lee, did you want to say something just on there before we go to our audience?
Yeah. Very
okay.
brief. Yeah.
Okay, very brief.
I believe that we if we're considering the driving force for these smart issues, maybe we need the ways. One is from the IMO. We need some kind of conventions to push the industry to have the more innovations, to have the more applications. Another way is we need to have some time to get the main stakeholders to have the consensus. That's it.
Thank you. All right, well, that's the end of that session, and we'll go on to the audience. So please do keep putting your questions into the Q&A box. The first question comes from Chris Morley of Seatrade. Martin, in your opinion, what will it take to standardize protocols across the board at pace? Who needs to collaborate? And is there an existing pan-sector body that could drive that forward? Or is there a gap to fill? Martin, over to you.
Gosh, that's, I only ask the questions, I can't answer them. I guess I'd be looking at Mr. Lee, but I have, needless to say, I have a few thoughts on that one. I think that the people that need to be involved, the equipment manufacturers need to be involved, obviously, because it's no good, you know, having lots of different equipment which is producing information in different formats. So it would be good to do that. Although you can sort of hide equipment behind electronic control units. So you can sort of segment it within the ship in its own little area. But I think the equipment manufacturers, the shipbuilders, I think are going to have to really take another look at the whole functional system design on the ships, because it seems to me the focus is very much, has been very steelwork orientated recently. And so the process of putting all this electronics, of doing electronics on the ship and networks, rather than lots of direct wiring and so forth, that's a very big job for the shipbuilders. But they need to be involved. And of course, all of this is going to be expensive, and the cargo owners need to pay. I think, you know, Christian raised the point about Yara getting involved. I don't think you wouldn't build a ship like the Yara ship to trade on the spot market, that's for sure, because nobody would pay for it. And so I do think that the cargo, when I first started work, you know, most of the tanker fleet was on 10-year charters, and you could get enough money from the charter to pay for a good quality ship. And I don't think to do this sort of technology, you need more than the promise of the spot market. Those are my 3 points really on that.
Thank you. Anyone on the panel would like to take that?
Well, I would be interested to hear Mr. Lee's view on how the ISO and the IMO would find each other to at least discuss portions of this question.
He's got his hand up. Mr. Lee, the floor's yours.
Yeah, very short. The Chris Morley has had a very good question. So I agree with collaboration and for the existing body. So I think that ISO is maybe it's a very important standard body, because ISO is NGO in IMO, and we have many links with IMO to support as a linking instrument. So, but actually, even though we need a consensus, so we need a lot of time, because now the cutting edge technologies, the innovation made by the different private sectors individually, but the consensus needs the stakeholders to sit together to argue, to have a lot of argument, and you know, that's negotiations and compromise. So we need a lot of time. So that's the way we do business. Thank you.
Okay, we go on to the next question, which is asked from Philippe Depagne. Good day. How about wireless on board versus wire? Who would like to take that?
Well, I can take part of that. Of course, wireless is a big topic on board. The environment is not in our favor there, of course, because of all the steel everywhere, and we can't circumvent a Faraday cage. But you still see a lot of developments in making sure that Wi-Fi signals or other radio signals can be transported with devices that are on both sides of a steel cage. And definitely Wi-Fi and radio, short-term radio, will play an important role in asset management and also crew welfare and safety. So I don't think it will very easily replace a cable bus on a vessel just because of the technicalities of it, but it will come to a point that a lot of your networks on the vessel can be managed over the satellite links and until the Wi-Fi points. But what we see more and more are requirements for managed Wi-Fi points on board, and that is very doable nowadays.
Yeah, but if I may,
yeah, Martin, please go ahead.
Okay, I think there are two problems with the using a CAN bus network type of system. I mean, one is that you've got the arbitration issue, which you do really need. I mean, the trouble with Ethernet type of systems or any other is that you can't guarantee that the right messages get priority or that messages don't get lost. And the key thing about the CAN bus type of system is that you need the ability for the recipient of the message to check back and establish the priority very quickly. And I think 60 meters is about, or 50 meters is about the maximum you can do at the moment, which is too short for a big merchant ship. So I don't know what I think there is a technical problem there, but the point I'm really making is that that wireless doesn't really meet necessarily the issue of that security, that when you're actually running the whole ship by these messages between computers, you cannot afford to lose any. You've got a very, very high security standard.
I agree.
And I think wireless is there.
Christian, you had your hand up.
I just want to make, so we've been working on various, it's not we as Kongsberg, but interacting with companies working with various wireless protocols of everything from sort of Z-Wave, Zigbee, LoRaWAN, Bluetooth, and other custom protocols. Actually, surprisingly good results, even though there's a hell of a lot of steel in vessels. And I see that sort of as a somewhat of a, I dare say, almost a solved problem, I think. And it obviously makes total sense, because rewiring an already existing vessel is very expensive. So if you're doing any sort of retrofitting of equipment, if you wanted to, I think that's doable. Obviously, depending a little bit where on the vessel you are doing this. And so an intercommunication between these also, once you're on an Ethernet network, sure, you could argue that, okay, you might need some sort of guaranteed network, but there are software protocols today that support that. So I actually don't think, I believe, but then this is just my personal opinion, I believe what's hindering this is the fact that, retrofitting of this type of equipment, hasn't been enough sort of return on investment. Why should I do it? But we've seen some examples, but I think that's, I think it's technically, I think it's doable without any problem.
Okay. Can I just go on to the next question, because I know that this will follow on from this last one a bit. And this is from Jinbao Wang. How do you evaluate the role of 5G in the present and future advanced digital system? Mr. Lee, do you want to take that one?
It's a very good question. You know that 5G network provides the more broad width band rates for the users. So on the 5G applications that we can imagine and speeding up the transmission, and have the more applications of the format of the message, including the pictures, videos. This will great help for operation of the ships and the maintenance. I believe that it's a very good new generation network supporting our maritime the transportation. I believe that. But actually in ISO/TC 8, we don't, and not yet discuss about the application or the standards about 5G on board. You know, there is seldom the practice is experience on this application. So that's the main reason. We still need time to have more applications. Yeah.
Okay. Anyone else want to go take that question on 5G? Okay.
Well, eventually it will make the integration between onshore and offshore networks easier. As Mr. Lee says, the applications, the 5G applications give you much more clues on how to interpret the network underneath. So the seamless collaboration between shore and offshore networks is becoming easier. But the threat is that onshore, the cellular network operators are marketing 5G for the speed and for those kind of things to consumers. But I think the value for the maritime industry is in the applications that make the collaboration more easier. So you wouldn't like to confuse those two.
I think one point here that's worth distinguishing is the difference between the new building market, the new ships, where you're trying to put in perhaps, you know, fancy canvas type networks, and the existing ships. I mean, we've got 60,000 cargo ships trading at the moment, and the big question is what you can do with those, especially from an emissions point of view. And there is a lot of pressure. That's on. I mean, Stena have been very vocal about this recently, that you really need to be able to start doing something and retrofitting on existing ships, which is particularly good because you can trial stuff on existing ships. You don't have to sort of order the ship and wait 3 years to get it. So, and I think the 5G is one area of many that you might be looking at here, you know, to get things moving on the existing fleet of ships, which in many ways, as far as emissions are concerned, are far more important than the new buildings, frankly.
Thank you, Martin. The next question is from Junji Senda. Automation should be introduced into not only for ocean, but for terminals. But understand we have a lot of challenges like jurisdictions and unions. Do you have any insights how fast and who can break the current bottlenecks? Would anyone like to take that one?
Well, I could say a word about single windows, which is something we haven't mentioned, but this, had I done, it looks like maybe Mr. Lee might know a lot more about it than I do, but there was about 10 years ago, they started, the biggest problem with the ports is getting the many pieces of paper that you need to get the cargo through the port quickly in the right place at the right time, 30 or 40 bits of paper. And they came up with this idea that you had a single window and everything got channeled into that, you know, that collected all the paperwork. And as I understand it, that has not made fantastic progress. It's sort of over 10 years, it's moved forward in committees, but, and has been trialed a little bit. I don't know whether anybody else on the panel knows, you know, has got an update on that.
Yeah, and I have a very short comment. I believe that just now I mentioned technology or digitalization, the applications on the maritime industry. We have two ways to push forward. One is from the convention, the mandatory, but it seems very difficult because it's quite different situation from the marine environment protection. So another way is we have our business, the maritime community consensus. So, but it's very difficult for the consent because you need to pay for that. So that's quite different from the different owners. So the practice depends on the individual actions. For example, in China, where I noticed the supports have upgrades to the code. For example, in the container the container ship, the ports in Qingdao, Tianjin, they are very automatically, and in some cases we can say that it's very smart, controlled, operated. So I believe all the case by case, after a long time, the practice that we can find, it's automatically to the industry consensus. It's a common action. So at that period of time, maybe we can say, yeah, it's a time for us to make a large kind of a scale of the standard, large of the scale of the actions. Maybe at that period of time, we will still need a lot of time because we have no mandatory rules. That's my point.
And come down to the last two questions, and the second penultimate one is also a little linking with this last question. And this is from Lloyd de Souza. Are the ports moving towards a commonly accepted EDI software by ports? Some are using TradeLens, Opus Terminal M. Would anyone like to take that one? Martin, any comments?
Unfortunately, I'm sorry, I have to confess, I was trying to read the messages and I didn't hear what you said, Chairman. So.
Okay, so are the ports moving towards a commonly accepted EDI software by ports? Some are using TradeLens and Opus Terminal M.
I sat in on a Zoom at the beginning of the lockdown, which there was about 30 ports involved in around the world, and they briefly reviewed their position. And to be quite honest, the impression I got was that there was not an awful lot going on. It's very difficult. In a way, the problems that you face are getting the cargo through the ports, and the sort of automation and that type of thing is coming along slowly. People are doing it where they can, but the scheduling of craft and the getting charterers to accept just-in-time arrivals and that sort of thing is it's all problematic. So I came away from that particular gathering, which I felt was quite a good cross-section, feeling that this is still moving rather slowly.
Okay, for the last question, if I could ask each of the panelists to give a brief response. This is from Paul Bartlett. We've heard a lot about agnosticity and collaboration, neither of which are characteristics of the highly competitive shipping business, either amongst its principals or its suppliers. How can a collaborative approach be inspired and managed? Who would like to take that first? And if it could be brief.
And it must be brief as well.
Well, we're going to do four people.
No, all right. So no, I really think that the OEMs and the shipyards and the communication platform providers should at some point join together to make this easy, because I believe that for all of them there is financial benefits to do so. And I see those collaborative discussions happening. It's not going quick, but I think eventually you will see those three coming together, whereby the shipyards are providing a much more holistic after service once a vessel leaves the yard, where you come to the kind of a vessel as a service, and where the communication platform provider is hosting the applications that the OEMs provide to deliver that service. Those three parties have to come together at some point, and it's early days, but it is definitely the beginning.
I can make
Christian, yeah.
Tag team what Ronald said there. I view it in the same way. I think if each certain of the OEMs or larger companies were to build this completely by themselves, I think they will see that there's actually quite a large investment that needs to be done. and you're really just duplicating something which is a necessary evil, which is what I refer to it. And what we're doing now, to me, is a necessary evil. We're fixing a hard problem, and fixing that without having other people on board just wouldn't make sense for us. So you can see we've done the announcement with DNVGL, we've done an announcement with ABB, and we're talking to lots of other partners to try and see how do we come together to fix a common problem, and take us together into the future.
Yeah.
Right.
Ronald, do you want to say something on that?
Well, I think it's an easier problem to solve than the EDI software and port question that we had earlier. Because I think for the yards, the OEMs and the satellite provider or the communication platform provider in that way, there are tangible benefits of not having to duplicate all the stuff. So, yeah.
Yeah.
Mr. Lee, can I ask your comments?
Oh yeah, I just very short sentence. If we consider the smart shipping, so I believe that we have the new ecosystem to be formed based on the stakeholders with a very common interest. Then we can move forward quickly.
Yeah.
Okay.
We are currently talking to many of the shipyards because they all see this benefit straight away. That if they can have the vessel coming off the yard with an agnostic platform, including the communication, that gives them the opportunity to provide this kind of long-term relationship with the owner of the vessel. So I think it goes quicker than you think, and that is the reason why so many platforms are already installed on the yards and having Fleet Express and things like that on board already before the new owner takes ownership, actually.
And for the last comment, Dr. Martin, over to you.
Well, three short things. I think I do sense there's a lot of competition between suppliers in this area, and for very understandable reasons. And I think that is an issue. But I think, in a sense, my answer is slightly tangential on this. I think the second point is that people and technology. I mean, my sense, I've been talking about smart shipping to anyone who will listen for 10 years now. And my sense is that even if you manage to persuade the principal in the shipping company, he goes back to his office and who does he talk to about it? You know, I mean, there's a few companies have spent. So I think a good start would be to have more people hiring a few technologists, even if they're young graduates, that they can, you know, they can talk to about these things. And then the third thing goes back to the question of new and old ships. I think that people should be looking at retrofitting stuff and learning by doing with their existing fleets. And I think the more that, you know, the people on this panel who are all deeply involved with this can support that sort of activity, the better, really.
Well, I'm afraid our time is up. That was fascinating. I'm sure you'll all agree with me. Thank you very much indeed to the panel. And I'm sure the audience will all join me in thanking Dr. Martin Stopford, Ronald Spithout, Christian Muller, and Mr. Lee. I do hope, as I said in the beginning, you have found today's webinar most insightful. Thank you. Today's session has been recorded and will be available early next week on the Marintec China 2021 website. The Marintec China team will also be in touch next week with all of you as to your feedback on the session and to advise you of the next part of this Marintec China Insight program. Thank you all for joining us today. May you all stay safe and healthy, and speak to you again soon. Goodbye.
Thank you. Bye-bye.
Bye-bye. Bye-bye. Bye-bye.
Thank you all.
Thank you. Thank you,
panelists.
Martin. Thank you.